Problem 56 states, if a car stops suddenly, you feel thrown forward. We'd like to understand what happens to the passengers as a car stops. Imagine yourself sitting on a very slippery bench inside a car. This bench has no friction, no seat back, and there's nothing for you to hold on to. So, the goal of this problem is going to be to determine what forces, if any, are acting on a person in a car when the car changes from a constant velocity to accelerating or decelerating. So for part A, they just want us to draw a picture and identify all the forces acting on you as the car travels at a perfectly steady speed on level ground. So here we have our car with our person on the inside. The forces acting on the person at this time are a gravitational force pushing downwards perpendicular to the bench and the normal force pushing upwards perpendicular to the bench. Moving at a constant velocity with no acceleration, so zero acceleration. And because we are at rest at a constant velocity, our net force is going to be 0. So part B, it wants us to draw a free body diagram, identify if there's any net forces acting on you, and if so, in what direction. So we have our normal force pushing upwards and our gravitational force pushing downwards here on our coordinate system. The net force is going to be equal to the sum of all of our forces. We know because we're at rest, our gravitational force is equal to our normal force, so our net force is just going to be 0. So because our net force is 0 and our acceleration is 0, we say that our car is an inertial reference frame, which means that Newton's first law is valid. And Newton's first law states, an object that is at rest will remain at rest, or an object that is moving will continue to move in a straight line with a constant velocity, if and only if the net force acting on the object is 0. So that applies here, but part C wants us to repeat parts A and B with the car slowing down. So when we start to decelerate, looking at our person, we still have the gravitational force and the normal force acting on us equally, but the car is now going to be decelerating. So it's going to have a acceleration pointing the opposite direction. So same thing with our free body diagram here. The net force is still going to be 0 when looking at our person. Part E wants us to use Newton's laws to explain why you seem to be thrown forward as the car stops and if there's really a force pushing you forward. So here we can explain that, Part D described what happens to you as the car slows down. So part D, as the car slows down, there's still no horizontal force acting on the person, but the car is decelerating. So the person is accelerating, but only in the car's reference frame. So this is no longer in the inertial reference frame, so Newton's first law is no longer valid. So we're only accelerating in reference to the car's frame. So to use Newton's laws to explain why we seem to be thrown forward, we can say that when the car is decelerating, it's no longer in the inertial reference frame, and Newton's laws are no longer valid. So we would think that there's a force pushing us forward, but there's not. Technically, the car is the one throwing itself into you. So that is why we seem to be thrown forward, but there's no forces actually acting on us. So finally, for part F, it wants us to suppose that the bench is not slippery. As the car slows down, you stay on the bench and don't slide off. So what force is responsible for your deceleration, and in what direction does this force point? Include a free body diagram. So now that the bench is not slippery, it has a static force. which is going to be pushing parallel to us, opposite in the direction of acceleration. So this static force is going to be pointing left on our free body diagram because it acts in the direction that prevents slipping, and our net force is still going to be going forwards because it's in the direction of our acceleration. We are accelerating now because the static force makes us decelerate. And the context of this question is to reinforce our learning goals from this week of recognizing what does and does not constitute a force, and to identify all the forces acting on an object, and also to be able to explain and draw an observation on the basis of physical principles.